Hello and welcome to Engineering Thoughts, where engineering minds come together to discuss topics relevant to our industry. I'm Vanessa Seeley-Fisher, and today I'm joined by Richard Gundersen. Now, Richard is an engineer, an innovator, and passionate advocate of STEM education. Richard is now a retired managing director of BBE Projects, where he was involved with the design and building of mine refrigeration, ventilation, cooling and energy recovery systems throughout the world. So welcome, Richard. Thank you so much. We're delighted to have you.
Pleasure to be here. Thank you.
Now, to kick things off as we get started, can you tell us a little bit about your journey into engineering and kind of what sparked your interest?
Yeah, I think I'm lucky. I've got some engineering genes in my blood from both sides of the family. And somehow I enjoy taking things to pieces, hopefully putting them back together again.
That's helpful.
And that's where it all started.
Excellent. Now, I know that you qualified in electrical and electronic engineering, which means you're incredibly clever, but you ended up finding a home in the mining sector in refrigeration and ventilation. And I'm interested to know the circuitous, perhaps, path you took to get there.
I'll try and give you the short version.
Thank you.
I studied in London at Imperial College, and at that time there were three very strong campuses. There were the miners, the engineers, and the scientists, and everything was in a triangular fight. So then my parents moved to South Africa, and my friends in mining said, "Oh, so you're going to go and join the mining industry?" I said, "Over my dead body, am I going to be in the mining industry?" So I came over to South Africa after I graduated. I had a job offer, but 1976 brought some other dynamics into the country. And in 1977, I was pacing up and down Fox Street and Main Street, knocking on all the doors of all the mining houses, asking if they wanted a young graduate from the UK. And fortunately, Goldfields of South Africa at the time said they've got people in the UK recruiting people like me, so it was only a pleasure to have me come and knock on their door.
Oh, fantastic.
So, and that's electrical engineering. I think passionately I'm a mechanical engineer, but I thought that I can work out for myself. With electrical, I haven't got a clue what's going on inside those wires and magnetic devices. So I actually decided I need to study electrical. And then I ended up being in the digital world. So computers were coming in at the time, and I became quite a whiz on computers. So that was...
Right. So you're the true engineer who's got the passion and the interest, and then you've educated yourself in the wide variety to get familiar.
So
That's
by now I'm a jack of all trades, a master of none. So
you're still a master. Now, for those who perhaps not familiar with what refrigeration and ventilation really means, particularly in the mining sector, could you give us a little bit of an outline of what it is and perhaps some of the challenges from an engineering perspective?
Sure. Yes, it's air conditioning on a grand scale. And these are large machines. They've got motors in the megawatts, not in the kilowatts. The rooms are the size of the small factories. And the heat exchangers, where the air and the water change thermally, are quite large structures. So that is, I guess, the background. The components are simple. There's a refrigeration machine, there's a cooling tower, and there is an air cooler, which might either be a direct contact with air and water, or it might be an indirect device, depending on the circumstances on the mine. And I think, strangely, every situation we've encountered has been a different solution. It's a modification, it's a variation on a theme, but certainly not a standardized solution. So
right. That's very interesting. So you've had this wonderfully varied career, although in one sector. If you look back now, could you identify perhaps a project or a mentor who maybe changed the way you think about engineering?
I think I was lucky. I didn't appreciate it at the time, but I can see that my grounding from being a junior engineer on the mine to being allocated to a section which had relevance to what was planned for my future, I think, and then the move into head office, and then the strange diversion into the mining side of, never mind the engineering on mining, but actually going to the mining department to go and do some ventilation. That was quite an eye-opening chapter. But looking back, I can see the people who actually pushed me and encouraged me and gave me a rope long enough and said, basically, this is what we expect of you. If you need help, put your hand up. So I had 2 or 3 good senior engineers above me who trusted me and made it clear what they were looking for and left me to get on with it. So that's invigorating. That's quite special.
And encourages you to find solutions to the problems, because over my dead body am I going to ask for help, which probably stretches
There's
you.
There's a bit of that, yes. So I don't know if you heard STEM. That is often called STEAM.
Yes.
So they want to bring art back into the STEM world. And a lot of good engineers actually have a creative side to them because they do take the building blocks of what they know, but they try and reassemble them in a way that will tackle whatever the current problem happens to be.
Right.
And in my job, that even struggled. I went through to logistics, so shipping and other things about getting projects going in strange countries in Africa. There was as much agility in solving the logistics of getting there as there was in actual engineering design of the solutions. So.
Wow. I do see that, and it's a lovely analogy to see the artist in the engineer. I think that's a beautiful analogy. Now, if we go back to your core working life in the refrigeration, the ventilation sector, it spans several decades. Have you seen significant changes? Every other facet of life has changed dramatically.
Strangely, not a lot.
Okay.
So the building blocks, as I say, are pretty much, it's the solid engineering items that we've been playing with for the last 30, 40 years. But energy certainly has become a major consideration. And the equipment that we work with actually is quite a high consumer of electricity.
Sure.
So there's a lot of energy involved. That's why you'll see somewhere we got involved with energy recovery. So more on the mines. In my previous career with Goldfields, we were putting energy recovery devices into deep mines. I think to this date, we still install the world's highest head turbine. I can't say deepest because we started so high above sea level that the turbine itself is not far below sea level once you're 2,000 meters deep in a gold mine. So anyway, that had a head of 2,000 meters. That's quite some pressure.
Exactly.
And that was a 5 megawatt Pelton wheel. I believe it's still running today, which is some 20 odd years later. Yes. So yeah, the rest of it is actually trying to make the systems very energy efficient and optimization, time of use, storage of product that you're making. Maybe you can make it cheaper overnight. Maybe you can make it colder overnight. Then you've got to store it. Then you've got to buy bigger machines. So it's a trade-off the whole time. It's a trade-off, and the parameters that we take into consideration, those values are changing because of the modern trends.
That is interesting, and I'm sure that the more recent focus on energy really honed in on that. Sure. I mean, the catchphrases are energy efficiency and energy saving, and now you talk about energy recovering.
So we have some other catchphrases. We have time of use, ventilation on demand. So basically, in the past, we've generally ventilated the whole mine the whole time. And we actually worked out that we can keep a background ventilation going and then just direct additional ventilation as and when it's required, depending on movement of vehicles or moving of mining activities. So we're a bit more agile in terms of switching on and off than we used to be in the past.
That's very interesting and very practical in this modern era where we are increasingly aware of the need to conserve everything.
Yeah.
It's encouraging to hear that we don't just turn the lights on and walk away, but that we, in your case, turn the air on. In terms of AI, this is an aspect that's really fascinating to me. What do you see AI doing in the ventilation and refrigeration sector? And will there still be a place for humans in the sector?
So, first of all, I like to think of AI as applied intelligence rather than artificial intelligence. So it's actually a matter of taking the knowledge that we have and getting devices, computers, to make quicker, faster, more accurate decisions because they can process data much faster than we can. They can react to circumstances pretty quickly. You can be home at night doing, having a good sleep. Meanwhile, the mind is being managed by your AI system. So it's an extension of the exotic control system we've actually been using for a long time. Right. And it's just building in the fact that processors are far more powerful these days. And we can bring more parameters into the calculation so that they can be more intelligent, basically. But it's applied intelligence. It's not artificial. It's the way we actually use what we know and get it to make good decisions on our behalf and take the slog out of a lot of the jobs that we do.
Yes.
So, and in fact, a lot of our designs are simulations, trade-off studies. Now, if you can spend a week or two looking at half a dozen alternatives and considering the best solution, because you're now processing a whole range of working
parameters,
or configuration. Configuration is the word I'm looking for. Then you're going to build a better system, or more flexible, or one that's better tuned to the long-term requirements of the mine. So the AI actually is kind of, in a way, in the background there helping us, but it's helping us. It's not. I don't see it replacing us at all. It just makes us better because it's adding another dimension to what we can do.
Excellent, and I like that perspective. Now, Richard, if you were going to be mentoring a young aspiring engineer today, looking back over your experiences and the prospect of AI more influencing them, is there one specific thing that you'd encourage them to always keep in mind? Or more?
No, more, yes. Somehow to be an engineer, you've just got to have that in you. You've got to have that curiosity, that problem-solving drive. That it's not a job that you can be given a job. It's a job that you want to do. And you've asked me, I've been in the industry now for however long. I mean, I've enjoyed every moment of my working life. So I've enjoyed the challenges that have been brought to me. There's nothing better than building something and pushing the start button and having it work after, whatever you've been through to get there. And so for youngsters, expose them to that world, the thrill, expose them to that sort of being there and designing and seeing it through to actually being built and operating. That to me is probably the thing that will inspire them most to carry on and to persevere. So
excellent.
I haven't quite answered your question, but that's sort of
Well, I think it's to be passionate and to always find something to be passionate within it. And that's wonderful. Now, you're both an engineer and an educator. I'm going to ask you what has kept you passionate about your missions after all these years.
Yeah, I think there's always been something new. Somehow, as I said, we moved from doing design work into actually doing building, which I had done with Goldfields before. And so I had project management as a sort of a secondary thread in my CV. And we started doing projects, as I say, in sort of odd places in Africa with strange logistics. And I didn't quite stop being an engineer, but engineering became a lesser part of what I personally was doing. So I had engineers working with me, and I was sort of trying to always outguess what's going to happen, try and be one step ahead.
Yes.
And we had some nice incidents that we look back on and say we got around it, we made it happen.
And you can look back and be proud.
That keeps me going. Yeah,
Excellent. Yeah. Richard, this has been a fascinating discussion. Thank you so much for taking time to chat with us, to share with us a little bit more about refrigeration and ventilation as a career. It's been really interesting, so thank you.
Well, thank you.
And thank you for tuning in to this episode of our Engineering Thoughts series. Don't forget to subscribe and turn on notifications to ensure that you do not miss another video. We'll see you next time, and until then, stay curious.